So that we don't fall behind in the lecture, unfortunately, I do have to cover new material today. The good news is this will be actually a good review for some material on the test. Okay, section 3.1, quadratic functions and applications. How can you distinguish a quadratic function from a linear function? Good. Squared is the highest power, as opposed to 1 being the highest power. So any quadratic function can be written in the form ax squared plus bx plus c. Yes, this is true. And a is not equal to 0. Is that guaranteed to be a function? Will it guarantee to pass the vertical line test every time? Sideways parabola? That's a good question. Yeah. So this is of the form y equals ax squared plus bx plus c. When you can solve for y, it's a function, essentially. So sideways parabola, it's a good point. X is equal to a y squared plus by plus c, which is not a function. Fails the vertical line test. But we'll just talk about these for now. I hope your homework doesn't have sideways parabolas. I don't think it does. Okay, first we'll analyze what do different graphs of these look like. So I can plug in any number for A, B, and C, and we'll make a different parabola. So these look like U's. Some of them are pointing upward. Some of them are shifted to the left, up to the right. Some of them are reflected downward and wider or shorter. Maybe I should review a little bit about what's going to be on the test. Let's talk about this one. The base function would be y equals x squared. What should I do first to graph it? First, you do horizontal translations. Are there any? No. So y equals x squared looks like this. Okay. Then, since there's no horizontal, what's next? This 1/10. Is that vertical or horizontal stretch or shrink? Vertical because it's on the outside of the square, right? If it was on the inside, then it would be horizontal. So on the outside, we would say, is it a stretch or a shrink? Shrink, because it's 1/10. So it makes the height 1/10 the size. So if I take this point here and make it 1/10 the size, it looks more like this. Then I do what next? Reflect across the x-axis. And what next? Shift up 1, and I get to the blue one. Okay, so you'll have that mastered by tomorrow, right? Okay, great. So these U's, they can be upward, downward, wider, shorter, taller, blah, blah, blah. Any translation. The most important point on the graph is called the vertex, and this is a formula to quickly find the vertex. Bless you. So it says that if my function is in the form of ax squared plus bx plus c, I just need to know a and b, and I can find my vertex. Do you believe me? Negative b over 2a? Could be a typo. How could we verify that? Where did this formula come from relative to this? So they complete the square to find out what are the translations. So we could complete the square on that to get this formula. Do you want to try it? Or would you rather just memorize the formula? All right, we're going to memorize the formula. Not hearing strong opinions. The axis of symmetry always goes through the vertex. So if I have a parabola, the vertex is the highest or lowest point, and the axis of symmetry is that vertical line through it. So it turns out that is x equals negative b over 2a. It's the x value of the vertex. Parallel to the y-axis, because it's vertical. Oh, I guess, sorry, through vertex. And the equation is x equals negative b over 2a. Let's try to apply this. Okay, so if we have a parabola given in this form, ax squared plus bx plus c is equal to f of x, we're going to first look at the leading coefficient, that is a. And you say a is 2, and say, is it positive or negative? Positive, so that means it's an upward parabola, or an upward u. Let's see. Why is that true? Why does the lead number tell us if it's upward or downward? So let's say if I graph a parabola, if it's an upward u, it's based on really, if I go far to the right or far to the left, is it going up or down? So far to the right are values of x like what? What's the x value that's far to the right? 100? These are numbered. What are values that are far to the left? Negative 1,000? Sure. Okay, so think about if I plug in 100 to this equation. 100 squared, 10,000 times 2. How does that compare to negative 8 times 100? Negative 800 is a lot smaller than 20,000. So what if I plugged in a million? A million squared is way bigger than just a million. So for large values of x, these don't matter. This will always win out. So that's why we care about the positive 2. The positive 2 means it's going to be going up. If it's negative, it'll mean it'll be going down. Let's find the vertex. So to find the vertex, we need negative b over 2a. What's my b value? Negative 8 is b. Negative 8. Okay, 2 times a. What's a? 2. We simplify, and we get positive 8 over 4. 2 is the x value of the vertex. How do we find the y value of the vertex? You plug this in to the function to get the y value. So the function is 2 times x squared minus 8 times 2 plus 3. And we simplify to get 2 squared is 4 times 2 is 8. 8 minus 16 is negative 8 plus 3 is negative 5. So we found the vertex is 2, negative 5. Any questions about that? All right, so I'm going to just graph this point first. Negative 5, 2, negative 5. And I put it at the lower region of my graph because I know it goes upward. So I left room going upward. And we say, what is the axis of symmetry? It's x equals the x value of our vertex 2. So it's a vertical line passing through the vertex. That means I only have to draw half my graph, and I know the other half will look exactly the same because it's the line of symmetry. Do you want to draw the right half or the left half? Half? Sure. So if I do the right half, I would plug in what values for x? We've already plugged in 2 and got negative 5. 3 and 4? Okay. Why might it be nicer to plug in values like the left half, 1 and 0? Smaller numbers into the function. So if we plug in something like 0, 2 times 0 squared is 0, minus 8 times 0 is 0, plus 3, I just get 3. So 0, 3 is here on the y-axis. And plugging in a number like 1, I would get 2 times 1 squared is 2, minus 8 times 1, 2 minus 8, negative 6 plus 3 is negative 3. 1, negative 3 is here. So I know that my points will look the same on the other side. This is 1 away from the axis of symmetry, so I have a point here corresponding to 3, negative 3. This is 2 away, so on the other side I have something symmetric. 2 away on the other side, 4, 3. You can plug those in to verify, but then this generally has a smooth U shape going through all these points, and we draw an arrow, show it's going in this manner forever. Forever to the left and up, forever to the right and up. What's the domain? The domain of all parabolas is negative infinity to infinity. You can plug in any number, and it's going to give you a real number. What's the range? -5 is the smallest y value, and it goes up forever. Do I include -5? Yes, it is a point on my graph. It is a vertex. Any questions about this? Standard form of a quadratic equation would be if we complete the square, then we can always put in this form where you factor out the a first, and you'll have x minus h squared plus k, where hk is the vertex and x equals h is the axis of symmetry. Okay, so once again, what if a is positive? It opens up. A negative opens down. Downward u versus upward u. Can any quadratic function be put in standard form? Yes, by completing the square. We get practice completing the square, which may show up on your test. So let's practice. Put this function in standard form. F of x is equal to -x squared plus 4x plus 2. I first need my leading coefficient to be +1, so I should do what first? Yes, in the test tomorrow, we'd multiply both sides by -1. That's right. But for now, we can't do that because it's not an equation, it's a function. We factor it, yes. So -1, and I'm only going to factor it from the first two terms. X squared minus 4x. And I want to add a very special number here that will not change my function. What number can I add to not change my function? 0. Okay. Okay, but a very special form of 0. So what's my formula to complete the square? If my leading coefficient is 1 and my b value is -4. Yes, so this is what we need to know for the test. You divide it by 2 and you square it. What does that give us? Yes, -2 times -2 is in fact 4. So that special form of 0 I was talking about, x squared minus 4x, is +4 minus 4. So I haven't changed things because I just added 0 in the form of +4 minus 4. What was the point of that? The point was that now this is a perfect square. X squared minus 4x plus 4. What does that factor into? X minus 2 squared. Just verify. -2 plus -2 is -4. -2 times -2 is +4. I still have the -4 here, the +2, and the -1 out in front. So now I need to distribute this -1 to both terms here to get -1 times x minus 2 squared plus 4. I guess I'll do this in red. +4. -1 times -4 is +4. I still have the +2 here. And finally, my last step. Yeah, 4 plus 2. All right. Does this parabola open up or down? -1 is less than 0. Opens down. It's a sad face. What's my vertex? Very good. It's the opposite sign. What are you subtracting? So it's 2. And you just take the 6 as it is. 2, 6. And what's the axis of symmetry? Very good. The vertical line through this is x equals 2. Okay. Let me ask you a conceptual question. Without graphing it, can you tell me the range? Yeah, we include 2. Good. How did you get that? It opens down, so it goes down forever, -infinity, and it goes up to the vertex with, oh, 2's wrong, sorry. Yeah, the y value, right, is 6. All right, let's practice that again. Slightly different problem. Let's complete the square. So first step is what again? My formula only works if that's leading number is a 1. So we factor out 2 from the first two terms. 2 times x squared minus 6x. We add 0, but what's the special form of 0 we should add? Plus minus what? Close, but not quite. So we take this number and do what? Divide by 2. So -3, and then square it. -3 times -3. All right, plus 9 minus 9. We add the plus 9 because now this is a perfect square. So it's what squared? You take half the -6 to make -3. X minus 3 squared. And then, so that used the plus 9, but I still have the minus 9. Any questions about this? What's the next step? Yeah, distribute the 2. Technically, FOIL is a binomial times binomial. But by FOIL, you mean multiply, and that's correct. So we have 2 times x minus 3 squared, and 2 times -9, -18, plus 19. So our function is equal to 2 times x minus 3 squared plus 1. What's the vertex? Yeah, we take the opposite sign inside the x, inside the square, +3, and a +1. And it should make sense why we take the +3. This is a horizontal shift by 3. So from 0, 0, we shift right 3, +3, and shift up 1. Okay, determine the axis of symmetry. X equals 3. What's the domain? It's all real numbers. So that's the giveaway point, right? Domains, all real numbers. Range. This is a tricky one. Yes, very good. Because it's opening upward, right? 2 is positive. A equals 2, positive. So it's upward parabola. We know the lowest y value is 1. And it goes up forever. We always include it. Vertex is a point. You know what the 2 most common complaints I get as a math teacher? Those are complaints, but not most common. When am I going to use this? And then I hate word problems. But these are contradictory, right? Because the word problems are when we use it. These are the applications of parabolas. We can often use a parabola to map real-life phenomena. And we would like to optimize a scenario, maybe maximize profit, minimize expenditures. So if your expenditures are a parabola, you'd say, I would like to find that vertex because that's the minimum value. Or if my profit is a downward parabola, I'd say I'd like to maximize my profit and find the vertex. So that will be my maximum value. And now we have the formula to do that. Okay, so when will my parabola have a minimum value? Yes, when what's negative? That's right. If A is negative, sorry, that would be downward, right? So we want A to be positive. I mix these up. Okay, so an upward parabola has a minimum. A downward parabola has no minimum. If you say the smallest value is -100, eventually passes below it. So downward parabolas have no minimum. They only have a max. If A is positive, then you can find the minimum value. If A is negative, then you have a maximum value. Find the minimum or maximum of -2x squared plus 4x minus 3. So will this have a min or a max? -2 is negative, so it's downward, max. It has a maximum. How do we find it? Okay, how do we find the vertex? -b over 2a. So we can either complete the square like we did, find the vertex, or you can use the formula. So if you forget the formula, then you have to complete the square. If you memorize the formula, it's faster. So what's b here? Yes, b is 4. What's a? Yes, -2. Okay, so what do we get here when we simplify? -4 over -4. 1 is the x value of the vertex. How do we find the y value? Yes, plug it in. F of 1 is equal to -2 times 1 squared plus 4 times 1 minus 3. 2 times -2 times 1 is just -2. Plus 4 minus 3 gives us -1. Is that right? So what should I answer? The max value of f of x is -1. And sometimes we care about where it occurs. It occurs when x is equal to 1. All right, let's answer this one. Find the range of this function. Actually, we've already done a lot of these. Okay. But this part would be good review for the test. For what values of f is f of x equal to -3? What does that mean? That's when is my y value equal to -3? It's really asking for which x values is that true. So f of x is equal to 2x squared plus 6x plus 1 is equal to -3. So it's a likely test question that I say, when is f of x equal to -3? Or what are the zeros of your function? What am I asking if I'm asking to find the zeros of your function? Yeah, when is f of x equal to 0? Would be the zeros. Zeros of f of x. Okay, so then we solve. How do you solve quadratic equations? We usually make one side 0, right? 2x squared plus 6x plus 4 is equal to 0. What's the fastest method to solve these? Factoring if it works. Quadratic formula, completing the square. I'm going to divide both sides by 2. Because it's an equation, I can divide instead of factor. So then I get x squared plus 3x plus 2 is equal to 0. And it looks like this one's factorable. X plus 2, x plus 1. So either x plus 2 is equal to 0 or x plus 1 is equal to 0. Which means x equals -2 or x equals -1 are the two solutions. It asks for the x values for which equals -3. So if you plug it back in, you'll get what? You'll get -3, yeah. All right, let's go to the actual word problems, optimization problems. A manufacturer of microwave ovens believes that the revenue R in dollars that the company receives is related to the price in dollars of an oven by the function R of P is equal to 125p minus a quarter p squared. What price will give the maximum revenue? First off, can you verify that there is a maximum to this parabola? What's A equal to? Whoops. A is equal to the coefficient of p squared, -0.25. Negative, downward has a max value. You don't have to graph this, but I just want to talk about why this equation works. First of all, do we know what revenue means? It's the money generated from sales. But we're not subtracting expenses or anything. So it's just, if I sold this many units, this is how much money came in. It's not profit, how much I made. Revenue. So if I sold, let's say I sold all of my microwaves for $0 a piece. What's my revenue? 0. I have no money coming in. As I increase my price, I make more money. And as I increase the price, at some point, people are like, this microwave is too expensive. I'm not going to buy it. And past a certain point, people stop buying my microwave. At a certain price, no one buys the microwave. Does this make sense? Okay. So how do we find the maximum of this parabola? Negative b over 2a. So what's my b value? 125. It's the coefficient of p. My a value, we already identified as negative 0.25. Negative 125 over negative 0.5. Negative over negative is positive. What's 125 divided by a half? So dividing by a half is the same as multiplying by 2. 125 times 2, 250. So how does this correspond to my vertex? Is it the x value or is it the y value? It's the x value. We found 250 is here. Do I need to plug this in to find r? What's the question asking for? What price will give the maximum revenue? Is it asking me for the maximum revenue? No, it's asking me for the maximum price, the price that will give the max. So $250 is what I should price the microwave at. And I'm done. Now, if it asks what the maximum revenue is possible, I would plug it in. Example 7, a farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals. Determine the dimensions that should be used to maximize the area and find the area of each individual corral. So I know I want it to be a rectangle, so these sides are all the same length. And this big side is the same length as the other big side. How much total fencing do I have? 200 feet. So what's my equation relating 200 with x's and y's? Maybe I could do x plus y plus x plus y plus what? Plus x plus x. X plus y plus x plus y plus x equals 200 total feet. This simplifies to what? That is 20. 200. 4x plus 2y is equal to 200. Essentially perimeter, but with extra lines in the middle. What do I want to maximize? Area, total area, right? So how do I find area of a rectangle? Yeah, length times width. Area of a rectangle equals length times width. So in this case, what am I multiplying? X times y times x? Sure. I have a problem here where I have x and y's. So I need to use one equation to substitute into the other. Let's subtract 4x from both sides. Then we get 2y is equal to negative 4x plus 200. Then we divide by 2, and we get y is equal to 2x plus 100. And we can take this and substitute it into this equation. So area, instead of being a function of x and y, area is now a function of x only. And it is negative 2x plus 100 times x. Can you verify that this has a maximum value? A of x, if I distribute the x, would be negative 2x squared plus 100x. It's a downward parabola. Okay, so what's negative b over 2a? Negative 100 over, okay, so a is negative 2, b is 100. We simplify negative 100 over negative 4, that's correct, is 25. Do I need to plug this back into my function? So determine the dimensions that should be used to maximize the area. So once the dimensions, we found x. So 25 feet by how many feet? Y is equal to negative 2x plus 100. We'll plug in 25. So negative 50 plus 100, 50 feet is the dimensions of the big rectangle. Okay, find the area of each individual corral. Yeah. You could divide 50 by 3, or you can multiply 25 and 50 and then divide it by 3. Either way will work. Okay, so area of small rectangle, 5 by 50 over 3. I don't know, what is that? Did you guys plug it in? 25 times 50, whoops. 25 times, wait, okay. 416 point, was it 6 is repeating? Square feet. That's all for today. So I'll be in my office for the next hour.